Good evening, everybody. I'm going to start desktop sharing. Hello, Daniel. Can you see the desktop okay? Welcome. So tonight, hi Karen. I was just wondering how the team project is progressing. Okay, very good. Just a reminder, don't forget to do 4 discussion items that are not the answer to the final exam question. Reminder to create your final exam questions for your chapters. I looked at it just a few minutes ago, and we've got 2 people who turned in questions for chapter 1, 1 for 2, 2 for 3, 1 for 4, 2 for 5, no for 6, 3 for 7, none for 8, 9, 10, 11, none 12, 14, or 15. So the end of this week, which is 4 days from now, well, 3 days from now, I'm going to close it off, and I'm going to just work the final, because I need time to review it with you on Tuesday, or if necessary on Thursday as well. Okay, so make sure that you guys get that done. And I want to review what we currently have because there's a couple of questions. So I don't know if we do that now or not. Let's do that now since I've got it open to that area. Okay. There was a question here. I mean, the format looks good. I haven't done any content editing. I'm just looking at formatting. Looks good. There was a question here, Robin. You didn't indicate a correct answer. And you only have 4 possibilities. And I didn't want both A and B. I didn't want those kinds of answers. Jader has a good question. Which is the correct answer for the question? And you need to correct the questions. If I decide to use any of these questions, I will change them. Okay? Just be aware of that. So I'd like you to correct them. That format looks good. That format looks good. 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 This might be a good example of how I would change your problems. For example, I might, like this has a specific answer to this question. I might make this one false and then change one to none of these. So it's possible that I could do that on your questions. So you actually have to read the question and read the answers and make sure that it makes sense to you. The other thing that will happen will be I'll sort those or make those answers random, in the sense of they'll be flipped around. Looks good. Once again, I'm just looking at the formatting, not the content. What I expect you guys to do is read through the content. If you have any questions, put a reply to that particular problem, like we did here with Robbins. This reply, I believe, went with this. So if you have a question, reply to that post. Then right here, you would reply to the post. Otherwise, when I get them, read through them all and digest them, I might have to change them because they may not be correct. So just be aware of that. And then next week, probably, let's see, once again, either Tuesday or Thursday, I'll review with you. I'm not going to show you the questions, but I'll go through this more on a content basis, okay, to help. Let's see. Yeah, I think that was the only one that, from a formatting, that was different than required. Yeah, these look good. Okay, so now you know what you need to do, and what's missing. So if you're doing 6, you've got to get that question in, or 8, or 12, 14, or 15. If you don't, then you won't see those questions in advance, whereas you'll get a chance to see these questions and understand them. All right. I talked about that. I did. Did you guys, hi Mega, did you guys have any questions? Any other questions? Okay. I'll go through the online session question in a minute. I wanted to go through the anecdotal below, and I opened up my solution to this programming project, and I wanted to, just illustrate that there's not a lot of coding in that program. So first, just a few notes here on the first PC, right, in 1981 by IBM. It had no hard disk. It had an A and a B floppy disk, 5 1/4 inch, and it was 360 KB. Okay, that was the maximum you had, and then the device was able to do 1.2 meg later. They just doubled the density of the disk. And then the 3.5 diskettes came out, and they could support 1.44 of storage. They had 2 surfaces, 40 tracks per surface, and then if you multiplied out the number of sectors times 512 per sector, you got 1.475 megabytes, of which 1.44 was user data. So you had like 80 tracks, on both surfaces, 18 sectors per track, and then 18 times that is this amount, times that is this amount. And that's how things were allocated on disk back then. The other remaining, I guess, 0.034 megabytes was the sector checking stuff that went on. And then there's a link that you could look at that. The PC2 came out, I think, in 82 or 83, and it had a 10 megabyte hard disk. And I remember at the company I was at, Syntex, we bought one just to have and look at, and I started playing around with it. And the language they didn't have a C compiler. They had Pascal. There was a Pascal compiler, and I remember working a little bit with that language. And it had a C drive. So your first two drive letters were A and B for both floppy, and then C for hard disk, device 2. This was device 0, device 1, from the BIOS perspective. Okay, then I wanted to share this story that happened. And this happened to me in Windows 95 back in either 96 or 97. I'm not sure when. I was booting up from the C drive, and I got from the BIOS a one-liner on the screen that came up. Said, error, invalid data. Okay. So the operating system wouldn't come up. So back then, you could use debug on the C drive. I used a DOS disk in the A drive to boot up DOS 6.22 from the 3.5 floppy that was in the A drive. And I used debug to read each sector of the disk until I got the error. So I was using these commands basically. I can't illustrate this because I can't get my floppy drive to work properly in the virtual machine. So otherwise I would have shown you this. But once you get in debug, you have a dash that tells you, and I think I showed you debug before. And so you want to load an address. So I was going to load it at address 100. And then what device you wanted to. I wanted the C drive, so that was device 2. And then what starting block, and then how many blocks do you want to read? And so I started with 1, and then I went to 2, 3, or 0, 2, 3, 4, 5, 6. I think I got up to like 200 or something. And then I got the error, the same error, this I/O error. And so then I knew what block I had. So I looked to the left of that block, and I looked to the right of the block. Okay, and what I saw was zeros, lots of zeros. But I didn't know what the data was in that block. But what I ended up doing was I ended up writing zeros into that block. And like L is load, there's a W called write, which will write from this address to this device at that block, and how many blocks. Okay, so I wrote zeros back to the bad sector. Okay, and then it was able to boot up. So what had happened is that sector, the checking that was done, for the sector, was off. So that this area here I just talked about for each of the sectors said, hey, I've got some kind of a problem. And that fixed the I/O problem, so it booted up okay. I was surprised. However, when I did a directory, the names were all crazy. They were all weird names. So I used my previously saved tree backup. I believe I showed you that. command. Is that correct? Did I show you the tree command previously? I think I did. No? Okay. Well, that we can run. So you can do like tree, and it shows you everything that's under that current tree of directories. Okay, and then you can save that to a file. Right? When you do a directory, you can save that to a file. And of course, I did this off the C drive, so I did it. Hang on. I did it off the root of the C drive. I'm not going to do it here because it's going to take too long. But I could do this. So tree, and then you would route it to your tree backup or something. And then you could type out tree backup text, and it's that same tree. So all I had to do, it was mainly a pointer to the high-level trees. All the subdirectories were named properly and all right there. So all I had to do was really figure out which directory had the subdirectories on it, and then just rename that directory. And that's what I did. So I used my saved tree backup text from a tree command to rename the weird back to their normal names, and everything was running back fine. It's kind of if you use, what am I going to say? If you use a simple operating system, you can do things like this. But we're talking about, for Microsoft, we're talking about 1981 to 2018. So what is that, 37 years? Yeah, 37 years of adding stuff to their operating system. It is so convoluted and complex that you couldn't do something simple like this to fix it. That's why I believe in backups. You really need to make sure you have backups of your stuff. Okay, that's the anecdotal. Let's go to the online question. I'll just go to quizzes. Pick it up from quizzes. Okay, this is week 10. We only have one more CC Confer question to do. And I want to fix something before we start this question. So don't answer it yet. Yeah, I didn't realize that that was set. I allowed multiple attempts, but I show the answer, which I don't want to do. I wanted you to review the sessions. That was the whole idea. So, but anyway, what happened was Canvas, it was a little different than Catalyst in how they handled the Catalyst quizzes. In Catalyst, I wouldn't let that happen. Okay, what operating system did Art have a BIOS error message occur? Yeah, but I didn't spell it that way. I said Win 95, no space. Okay? I'm checking it. Sure it works properly for you guys. Yep, looks good. Yeah, correct answers are hidden. Yeah, I never noticed that before. But I will my next time I do this. Okay, any questions on the online session question? I went through the anecdotal. Are any of you going to be doing the special programming project? Or at least attempt some of it? Probably not. Okay, Megan. Okay, what I provided you with was this information here. The input data file and the operating system parameter data file, and this document here, and then header stuff. So you could use your own data file if you don't want to use my data file, but it has to have the same data to run. I just wanted to make sure that you realize it's not as complicated or as difficult to write, and the reason is I have lots of comments in this code, right? This is the program. And if you look at the total lines of code, it's like 1,728 lines of code, but a lot of it's comments and a lot of, I'd say, every routine I have. If we turn on debug, pass the parameter of debug is yes, it'll print out all this extra stuff. So that's code you really don't need. So I would say, just estimating, probably have maybe 1,200 lines of code, maybe, really out in reality for the program. Yeah, I believe that's all the code that's there. A lot of it's comments. Lots of comments. Anyway, I'd say if you can, give it a shot. You'll get partial credit, even though you may not complete it. Okay, that's got to be turned in the same time as the project, which is the 25th. The 25th is the last day I'm going to accept any work. So that's 10 days from now. Okay, I want to stop a second and make sure I covered everything I wanted to cover with you tonight. Yeah, I believe I have. Do you have questions on anything? See, I posted something on takeaways. The one that I thought was pretty well thought through was this one here. The kind of takeaways that this person was talking about, to me, would be of value. I don't know, did you read this one, Mega? Are you doing the technical writing? No, that wasn't you. Okay. What's your major? What are you going for? Computer science. What's the specialty? Engineering, software engineering. Okay. A lot of times, I'm just going to say this because I believe it in my experience, is that some of the stuff that we talk about, that cues, we talk about management of memory algorithms. We talked about how the OS works internally with interrupts from the hardware perspective. All of those concepts are kind of, well, they're quite a lot to begin with. So you're not going to find a specific use maybe in your particular job, but at some point during your job, you may get a question or you may get a task that will lead you back to some of these examples that we've talked about. And that's about the closest I can get to your takeaways for you. Until you're asked to do something like a driver, to implement a driver, you're not going to see or use, you know, this concept, because we're not coding anything really. Yeah, some of the algorithms that we talked about are in use, you know, and we're talking about over time. You know, some of the simple, like for example, fixed size partitions of memory and fixed size partitions on disk, they could be handled with the same algorithm. But they're simple. They got more complex over time for performance reasons. And if I look at, for example, yeah, let me do that. I'll do a. This is the file, right, that I asked you to use, okay, as input, and then I'm going to send it to HexDump, which I explained how to use. And things of looking at the data structure, for instance, if you store a number, right, if you store a number, we used to, as a programmer back in the late 70s, 80s, I used to worry about storage space and memory space. So you would use integers of maybe 1 byte, you know, 1 byte integers to track data, or 2 bytes of integers for data. And then you had to worry about large textual data. All of those things were designed to keep the processing fast, and because you had limitations of memory. Well, and today, do we really need virtual storage today? I mean, if you think about it today, we got a ton of memory. So do we really need virtual storage? I only have 4 gigs of memory on my machine right now. Okay, and I just got another machine, and it has 8 gigs, and I haven't used that memory. And it's going to be, I don't know, Google bytes of data in the future. So the kind of things that you originally started with from a programming and a computer perspective, you don't have to worry about. And that happens over time. But it's nice to know the background, and that's what I kind of try to bring a light to, is this thing came from somewhere and some concept. And that's why I use things like these discs, talking about the background, is to get a feel of what it was like and the growth of operating systems, because they're so much more sophisticated today. But if you understand the basics, I mean, they're applied to all operating systems, and you're going to find that out in your projects. When you do your team project, you're going to find out that the concepts like buddy system on Unix and Linux, how that works. Hi, King. I don't know. Did I answer your question, Megan? Okay. Yeah. The other side of it too is when it's sort of like the light bulb effect. It's you have this information in your head, and you don't know quite what it all means. Down the road, something happens, and then you realize this is what Art was talking about. It clicks. It clicks on. I don't think that's in your case. I don't think that's the case. I think you have a pretty good understanding. But it happens in that, yeah, you've had that moment. It happens. And it certainly happened to me about virtual storage. When I was programming, I didn't understand virtual storage. I had somebody explain it to me when I was programming. And then what really happened was I went back to school and I got my master's, and during those courses I took, it was explained, and I understood it. It's, oh, that's what, you know, my colleague programmer was trying to explain to me. So it will happen. And the other thing too, just as a former student, you get out of it what you put in it. So the more that you put into doing stuff in the class, the more you're going to get out of it. That's the other kind of thing. And I do like the garbage in, garbage out examples too for computer programming. Well, memory, I mean, I'm not using a lot of memory right now. Yeah, I'm using close to 3 gigabytes. Yeah. And I've got 1 gig available. So I don't have to, you know, I don't have to worry today about when I write my programs, do I have to use bits or, you know, keeping everything small, because my disks are terabytes of data. I mean, it's so much more powerful today. It takes a lot of the worry of being a programmer than back in the 80s and 90s when you had hardware limitations. Okay, I don't know why this is. Okay. Yeah, well then you're right, Karen. Then you should be worried about it. That's right. Yeah, you have hardware limitations on the smaller devices, and that will start to improve over time. I always believed that you would have your computer on your watch rather than on your holding something in your hand. I always really thought that, you know, I would have a computer like you know, a wristwatch, but it would display a 3-dimensional image, right, that I could look at and move around with my other hand if I wanted to. That hasn't happened, but you know, that's my thinking of my kind of ideal interface. Yeah, that's right. Or, well, you know, I don't know about the glasses thing. It's happening now on the glasses, but I'm not as an older person, I'm not thrilled of having some kind of a thing always in my vision. I'd rather have another mechanism, another device than my glasses. But yeah, it's happening. The other thing is, I'm thinking about, you could buy chips now that have embedded in them the Linux operating system, and you can put together very small devices and have an interface. You would have your Wi-Fi on that little board device. What is it? I'm thinking of the Fitbit. The Fitbit has Bluetooth on it, and they connect to machines through Bluetooth. But when you're Arduino, that's what I'm thinking of. An Arduino, if I've got that right. Device. Yeah, and Raspberry Pi, yes. Right. Arduino, yeah. I've been to, yeah, if you get a chance, in Burlingame, Redwood City, I'm trying to think of where the San Fran racetrack used to be. Maker Faire, right. About 4 years ago or something. Was it 5? It might have been 5 or 6 years ago. I went a couple years in a row to the Maker Faire and bought a couple of their devices to play with. San Mateo, thank you. I couldn't remember where San Fran was. And that was cool. And if you get a chance, you guys should go. Have any of you gone? Good. Yeah, I mean, if they do displays there, they're in what I would call the bleeding edge of technology, and to me that's pretty exciting from a development perspective. For using it, if I were an IT director or IT manager, I tended to stay away from bleeding edge technology and stayed around what was called stable technology. It's been proven. But, all right. I should tell you about the pen computer, though, before I leave here on this evening. Back in 80, let's see. This is about 19 88. We had, I was at Syntex pharmaceutical company, Syntex Labs, and they had 1,200 sales reps. Okay, and a project was created in that time frame to give the sales reps a pen-based computer. and it was NEC's computer, and it was a pen-based computer that had DOS 6 something as the OS, okay? And the idea was that it had a plastic pen that would go over the surface of this device, and it was about I would say 8 inches by 10 or 12 inches size, and it was pretty heavy. And I mean, this was technology before its time. I mean, we've got it today, but this technology was leading edge technology. And the purpose was to go to a doctor, these are sales reps, they go to doctors' places and they talk about the products and they leave samples. Okay, the key thing is they leave samples. And a law by our Congress in 1987, this law was to track samples given to physicians, because a lot of samples that pharmaceutical companies gave, the reps were out there selling them on the market illegally, and they weren't really giving them to the physicians. Okay, they were giving them to their friends and things like that. So the United States government came out with a law that said you have to track samples. So it came to Syntex. They did it on paper. So we had a paper system, and I worked on that as a, let's see, when was it, 86? Yeah, I was a senior programmer analyst or systems analyst at that time. I can't quite remember my role. But we had a paper system, which means that they had to fill out a form. The doctor would sign the form, and what they wanted to do was to have this pen-based system have that form on it for the physician to sign using the pen, the plastic pen. And then they would log in. So this had to be modems. At this time they were modems. So they would modem into the mainframe in Palo Alto and pass that data. Okay, the project would cost quite a few million, but the development cost about 900,000 to develop this thing, and it never worked because it was bleeding edge technology. It just was way ahead of its time. Could it work today? Well, sure. It could work easily today on smartphones, right? Because that's what is on those, are those apps in today's world. But back, what was this, 30 years ago, it didn't work. And I still have this computer, by the way. I have one of the prototypes of it, and I kept it because I wanted to see what it was. And then a little bit later, I would say 2 years after this thing failed, I was given the project to get this up and running. And of course, I dumped this concept. It wasn't going to be there. I implemented another concept which did work, but the company by that time was being sold. So this would have been in the 90s, early 90s. Um, I don't know why we went through this example. It's just, I guess, to show how technology is created and yet not able to work. I guess that's why. Oh yeah, and the make thing. That's right. The make thing that I got excited about 5 years ago was 3D printers. I thought they were great, and they're used now everywhere in manufacturing to either prototype something or create the real item. Have you guys seen 3D printers work? Yes, they're great. And when I went there five years ago or so, I brought my son, who is working, my younger son, who works for a bus manufacturer company today, Gillig or something like that, I believe. Anyway, he bought one for $2,500 quite a few years ago and developed some things on it. I don't think he's using it today, but you have to have a reason to do that. But that's an example, I guess, of technology that's going to eventually find a place. This pen concept was a great concept, but the hardware manufacturers weren't ready for it. They just didn't have the operating system wasn't there yet, and the hardware was very bulky to deal with. The phones today are very easy from a hardware perspective, and they got a lot more capability, right? A lot more memory. I mean, DOS 6.0 is 512K. That's what you had of a program size, was 512K. You really can't do much with 512K. All right. Well, anyway, I think I've probably overextended my time with you guys. Are there any other questions? Kang, you came in. Do you have any questions? Okay, very good. Yeah, I went through all of this stuff, and you can review the recording. Very good. In that case, I'm going to say goodnight to you guys, and have a great weekend. Have a great weekend, and work on your projects. You've got time here. Work on your projects. All right. Have a good one. Thank you. There's on.